In the big bilge tank, we'll keep you in the know. In the big bilge tank, we'll fix your techie woes.
And we'll break things and we'll make things till we're all together raking and
We'll raise a cup of grog down in the big bilge tank. In the big bilge tank, come and join our pirate crew. In the big bilge tank,
We will show you what to do.
and we'll hack it till we crack it.
And we'll tell the world about it and forget to tidy up.
That's why it's now a bilge tank.
Hello and welcome to episode 002 of the Bilge Tank from Sheffield upon Sea. Today we're going to talk about PCB design and how we go through the process of designing our products. We're going to look specifically at the piano hat and Displaytron hat, and we're also going to have a chat about some of the interesting things that other people are doing with their PCBs.
Sounds good. So, PCB design, we have an array of PCBs along the front here, just to give you an idea of the smorgasbord of what we do. Yeah, some of these I think most of you will have seen before, including kind of the red pie here, just to show that commercially we do different things as well in the pie community. There are now green, red and blue pies out there.
There are,
Yeah.
yes.
Yeah, but we decided that wasn't good enough, so we went for Flotilla, all of these beautiful colours. First thing we're going to talk about Boldport a bit. So Boldport,
He's based in Cambridge.
he's based in Cambridge, or now London as well. Guy named Sar, you'll see him around the Cambridge hack space a lot, and he designs very organic and beautiful circuit boards that have been a bit of inspiration for us in making better circuit boards that are not just functional things, but have a design element to them, have some fun about them. Generally kind of make you happy to use them.
Yeah, there's a bit of a history of engineers doing slightly wacky things with circuit layouts and kind of embedding little graphics and icons and things like that, company names and even sayings and phrases. But Boldport's taken it to the next level. I think he even wrote his own software for doing the layouts of these things.
We'll cover that in a bit. So just to give an example, here's what he did with a kind of a build your own cheap Arduino kit. He made it into a seahorse. There's a previous version of this called the Cuttlefish, and then he went one up with a kind of this, great seahorse design. So it's got all these kind of the chip down in the centre there, and then it's got the battery and tail at the bottom, and it has these little add-ons that you can add with conductive thread, such as LEDs and the like, just for a fun way to kind of add on to the circuit.
It's almost like a kind of badge stroke wearables thing. I presume it was for an event. Was it?
Probably for an event. He does things for events. So he did a badge for a kind of French hacker camp, and he does these things. So circuit boards, they're built up of layers. In the middle you have the thick layer that forms the thickness of the PCB. That's generally made out of fiberglass or sometimes aluminium, but mainly fiberglass. And that's translucent and tends to look a bit brown and drab.
It's a bit thin for that.
Yeah, it's quite thin. Standard PCBs tend to be 1.6 millimeters thick. So like most of the hobbyist electronics, that's the kind of stuff you'll have. It's essentially a fiberglass substrate, isn't it?
Yeah. Most of our boards are two-layer boards, which means that it has two layers of copper, one on top and one underneath that fiberglass.
Look at that demo. Yeah. So when the raw PCB arrives before it's actually turned into the product, what you have is a solid slab of 1.6 millimeter FR4, which is the fiberglass material, and that's coated on both sides with copper.
Yep.
And then the actual process of manufacturing the PCB involves making lots of masks and kind of etching away with nasty chemicals and photo processes to end up with the final kind of layout.
Yeah, so this badge here, you can see that some of the copper has been left there, but some of the copper has been etched away, and the silkscreen layer that goes on top, so that light shines through the board, because that fiberglass is translucent, so light can shine through it. And Boldport is like the king of doing great effects with that kind of stuff. There's one example.
This is all about layering as well, because the PCB is layered with the copper, the fiberglass, the copper, and then when you apply finishes like the solder resist and the silkscreen, what Boldport does is it kind of plays with which layers interact with each other.
Yep.
And that lets you get a wide array of effects. So if you've just got solder resist and no copper underneath, and then FR4, you'll get a slightly different effect to if you've got the copper there, and you can mix and match all of these different features to do interesting things.
He also does these crazy functional things, like here's an engineer's business card, and you can slot components into there, and it will form a working circuit. And yeah, you would have seen this on Hackaday, because I think everything he does.
the one that basically had emergency components, so you always had a card with the components you might need in an emergency.
That's it, like a 10k resistor and an LED and a NPN transistor or whatever.
And he tends to do open hardware as well. Here's an example of the layout in his circuit design software called PCB Mod E or PCB Mod A. We're not quite sure, you can't tell on the internet. And again, that's if you want to use that, the source code for that is on GitHub. It's on version 3 now, and it is quirky, as all CAD software is, but yeah, serviceable. So go check that out.
If you bring back the seahorse a minute, I think one of the things that's quite nice is that, as well as, like, lots of people do slightly funny shaped PCBs, but he even positions the components and things to be part of the overall design.
Yeah.
He goes to town on it.
Yeah. And this contrasts with kind of us. We tend to use a piece of software called EagleCAD, and that's the default choice pretty much throughout the kind of hobbyist industry. I think we use it, Sparkman use it a lot.
It's
Adafruit
either
use it.
Eagle or KiCad, isn't it, basically?
Yeah.
They're the two that get used, but
Yeah. KiCad is the open source software. So if you want to kind of have an open source diet, you can use KiCad to make your circuit boards, and you'll find quite a few resources, increasingly so, online. So check out KiCad.
I think aren't the Pi Foundation supporting KiCad as well? The development of it.
I think they might be.
I'd heard something, and the development of KiCad's moved into CERN, I think, as well.
CERN gave it a lot of support,
Yeah,
didn't
yeah.
they, to bring it kind of up to pro standards.
It's
or more
moving very fast now. KiCad is kind of catching up much quicker than historically it has, which is good.
Yeah.
But a lot of hobbyists use Eagle because they had very generous licensing if you were not making a commercial product and you were only making things this big. But the second you go bigger than that, or you want to sell it, that's how they get you.
Yeah. So we use Eagle, and you'll find on our GitHub that we have a library of components you can use in your projects, open sourced on Eagle. Adafruit have the same, SparkFun have it too, as well as a lot of their boards. So .brd files and
SCH schematics.
So you get the schematic, which is the logical way the circuit works, and then the board design, which is the physical layout of the board. I think Phil's still working on his course for Eagle introduction. That's going to be a mammoth project.
It will cover off all of these subjects and more, basically blow by blow.
Sign up today, folks. Where can you sign up, Phil?
Eagle.gadgetoid.com, in fact.
Brilliant. We'll put that in the comments.
Sounds good. So we were going to look at Piano Hat as a particular case study. This is the panel for Piano Hat. Let's drop that under the close-up.
There we go.
So if you tilt that a bit to get the light to play off it, you'll see the copper changes colour there as the light reflects off it.
Generally, with a traditional PCB, the only bits that are exposed copper are where the components are going to land, because that's what makes the electrical
That's
contacts.
generally pretty good practice, yeah.
But obviously, it can be abused to become a design element. Oh, not abused, but you know, it can be a design element
It's
as
abuse,
well.
yeah. So there we've got the board that Eagleman designed for his Indiegogo
Not to be
project.
confused with Eagle CAD. That's Zachary Eagleman, who came up with the original concept of piano.
The Pi Piano, yeah. And we did our redesign. So we were starting with these kind of contact switches, tact switches, and we kind of went from that. We decided that they were a bit hard to press.
Yeah, and it overhung the Pi as well. It wasn't hat spec.
Yeah.
It was soldered together yourself
I
kit.
think at the time hat was only just becoming a thing, if not has only just become a thing. So
Yeah, but even without, he wouldn't have been able to fit the switches on a hat-sized board, I don't think.
no,
Because they're 12mm tacks, weren't they?
they're
So-
pretty big.
Yeah. So we were going to go through this obsession with hats as an emerging way for people to get introduced to the Pi, and an obsession with Cap Touch, which is just really useful.
I can't remember what the first Cap Touch board we actually did was. It might well have been this that then led on to the Cap.
Explorer hat.
Explorer hat was
Explorer hat had
Explorer
cap
hat
touch
came
on. Yeah.
Yeah.
And we were prototyping it on Flotilla before as well. So we're using it on a few things. So
We know,
we've
yeah.
got it on
Basically
Squaretron
everything.
and Cap Touch is just awesome. It's cheap to implement and it's really flexible. You can have
one of
pads
the
whatever size.
useful benefits is it obviously doesn't require anything to be placed in order to add buttons. So buttons come basically for free, which
Yeah.
is handy.
So if you're looking at this circuit board here, you've got landings for all components here, and if we look at the back, there is only a landing for the header that goes onto the Pi. When we're producing things, having to place things both sides of the board means it's much more complex, and we tend to get more rejects in manufacturing. So we try to design things so there's only components on one side, or like this, we have one component on the flip side. Let's take a closer look at that.
Yeah, the other thing about doing double-sided placement is that you have to do pasting both sides of the board. You have to load it in the pick and place a second time. It goes through reflow twice, but
Yeah.
if you can avoid it, it's better to avoid it.
Yeah, so that means we have to get canny about the other side of the board, because a lot of space is going to be taken up by that piano. And Phil kind of was tweaking this for days.
Far too long. Yeah.
Yeah, just to get that layout just perfect, and still keep the components in kind of logical places. We don't mind people seeing the components. We like people to kind of look at it, and as they learn how to use the Pi piano, they can say to themselves, "Oh, I now know that this here is a cap touch.
You need to reach further. Yeah, there you go. You're in cap.
This here is a cap touch chip, and here is a second one of the same cap touch chips, and here's the EEPROM for the hat spec, so that the Pi can auto-identify." And you can learn quite a lot from looking at these boards and asking questions of it and saying, "What is that? How does that work?"
Mm-hmm.
So this is one of the things we like about our circuit boards, being very open and obvious where stuff is and what stuff is. And pulling these apart and then downloading data sheets, you can learn a lot about design and electronics and how to lay out a board. Never use auto route, by the way.
No, it's
Yeah.
not worth it.
Not even
No.
once. It's not artistic enough.
Yeah, SparkFun have a really great article on designing good PCBs for manufacturing. Have a look on that. If you Google SparkFun PCB Design Eagle, it will have a list of tips on all the things you need to do to design a good first circuit board.
Yeah.
There's a lot of learning in there and getting it wrong, but with cheap kind of prototyping services these days, you can go a long way. Prototyping, we tend to use Ragworm a lot, Eurocircuits,
Yeah. It's
and
dirty PCBs.
Dirty PCBs now,
Yeah.
which is run by Dangerous Prototypes out in China. And it's kind of the most basic, don't give us any hassle, beautiful PCB service ever. We love it.
Yeah. Well, it's good for running off lots of kind of concurrent spins of stuff
Yeah.
cheaply, and just seeing what comes back. Really, see how it goes.
Mm-hmm. So you've got a choice there from kind of UK, Europe, China, depending on what your needs are and how cheap you want it. People in the comments will probably pipe up with the services they use as well.
Yeah.
We went for about 4 revisions of Piano Hat, I think, before we settled on the final thing. So,
How many times did you forget to put the fiducials on it?
well, all the first revisions, and then they came on the very final panel.
So fiducials.
This was
Yeah,
quite a
this
fiddly
is,
board to design, just because there's so many cat touch pads, and they're slightly smaller than they should be, really. But getting the isolation right took a few spins.
So Phil's pointing out the fiducial here.
If I can,
Yeah, that's a small dot there. Slightly out of focus, but we generally have 3 of those dots on each and every board on each side that's going to be placed, and they're used for the imaging on the pick and place machine. So its camera head can go over the board and work out how it's slightly rotated or offset. When you've got a robot placing components incredibly accurately, these are how it tells where in the world this PCB is and how to place components so that they are in exactly the right place, down to a really, really high tolerance. Otherwise, things don't work.
No.
And yields. Well, from early on when we were doing Unicorn Hat, we have a box of rejects that just did not work. And that was because we were kind of very early on in mass manufacturing PCBs. Well, mass manufacturing, medium-sized manufacturing of PCBs. We had to learn a lot of things about esoteric stuff like keeping moisture out of your creations. It was interesting times. Yeah, so I think we've talked a bit about PCBs there. We've got the Pi-K PCB here. Yeah.
Which one do you want?
Let's look at the
Should we have hot preview?
hot preview. Yeah. We kind of liked the red of the Pi-K PCB, and it wasn't quite what we wanted. We wanted the hot pink, but we ended up with red. So now we've decided we're going to go for the blue we had for Flotilla because we like that. So when we get our new batch of Pi-K PCBs, they will be this lovely blue colour.
So if you've got a red Pi-K PCB, that's now officially limited edition. Congratulations.
Totally. One quirk you might notice about the Pi-K PCB is that it's got 3 colours on there. It's got the black that is kind of our in-house trademark. Then it also has the white silk screen, and then it has a further third colour, which is the blue or the red. That's pretty non-standard in PCBs, and Ragworm kind of jumped through quite a few hoops to make that work in a way that was manufacturable. Because each time you print a new layer of ink, you get thicker and thicker, and there's a chance that components won't place, or that the registration will be slightly off, and it will make the design look a bit naff. But Ragworm kind of did some very nice hand silk screening of these boards to make sure they were spot on. But that's something you don't see very much. So if you're into PCBs, take a look at the Pike-A PCB very closely and look at the work they've done there.
Yeah, they've done a really beautiful job on this.
Yeah.
It's so crisp and so kind of lightly coated that, yeah, it's amazing, really.
Yeah.
It's good stuff.
Mm.
So soon we will be shipping blue Pike-A PCBs.
Fantastic.
Okay, should we move on? Should we have a look at Explorer Hat Pro?
Let's have a look at Explorer Hat
We
Pro.
thought we'd do a little demo so that people could get a feel for the features on the Explorer Hat Pro. Get on the little camera, let's get a placement for this. Where are we? Lovely.
So we keep talking about Explorer Hat Pro because we don't think enough people kind of get it, what it is yet. And the way we can find that is just by showing you exactly what it does.
Yeah, and how simple it is to do it as well.
Yeah.
So we've basically got two examples set up here, and you can't see the LEDs. Let's turn that around. There we go. I think like one of the most interesting features of the Explorer Hat Pro is the analog channels. The Raspberry Pi has no analog channels by default.
Yeah, people have been asking for that since like day one. And they just can't do it. The system on chip doesn't have it, and putting analog when not many people use it on the board adds cost, and that's just not what they do with the Pi.
Plus, with analog, there's a lot of choices to be made. Do you want like a basic 8-bit analog? Do you want 12-bit, 16-bit, Delta Sigma? And it's like whatever you pick is the wrong thing for someone else. Yeah, exactly. Sampling speed. So ADC chips, they're pretty common. They come from like 4 channels up to 16, probably beyond.
Yeah.
But they'll cost anywhere from 90p to £50 a piece, depending on the quality, basically. So there's no one right answer for any project, and it really depends on what you're going to do. What we did with Explorer Hat Pro is we picked like a good standard part, one that had been used by Adafruit for a long time. It gives you good performance. I think it's 12-bit ADC with decent sampling rate. But just by adding those analog channels to the Pi, you can now do some completely different things that weren't possible before. So here we've got a demo where we've got an electric mic. Do you want to go to that camera?
Yep.
There we go.
Presto change.
Oh, no, and the
Oh.
the close-up.
Yeah, close
Yeah.
up.
So we've got an electric microphone, which is an Adafruit breakout board, and we just hooked that up to analog channel 1 on the Explorer Hat Pro, and basically that will give us something roughly like 200 millivolt peak to peak when we clap over the microphone. And because it's an analog channel, we can detect that slight change in voltage. So if we go to the code, we'll have a quick look at the code, I guess.
Okay.
So it's a really simple little program, but basically we start off by importing the Explorer Hat library, and then we loop forever, reading the voltage from that analog pin. And I've just hard-coded in an evil magic number of 1.8 volts. But essentially, the other interesting thing here is I'm actually driving the microphone off the 3v3 rail of the Pi, because it's a cleaner power supply, so you get less fluctuation on readings from something like an ADC. So this microphone has basically a 0 value, which is the VCC supplied, which we're using 3v3, divided by 2. So if there's no sound detected, you should get something that is roughly 1.75 volts, and that would be like your 0 level. If we clap, then there's a little amplifier on the microphone board, and that will cause the output from the microphone to increase from that 1.75 volts. Not by much, I mean you're talking very small amounts, but we've just decided to threshold it at 1.8 volts. So if I run this program and go, and it's off, so go back to the other camera. Maybe.
Oh.
You can see it detects me clapping. The rest of the program basically incremented a counter every time it heard a sound, and then that counter is being output as a binary number on the 4 LEDs on the Explorer Hat. So we could either clap or you could talk loudly into it, and it should be able to pick that up, or whistle. So that's kind of cool. You could use that as I don't know, some sort of intruder detection thing if you hear a sound, or you could use it as a clapping light switch. It's quite a nice feature. You probably want to amplify the output from the microphone a little bit, so maybe use a transistor or something or an op amp maybe, just to increase that output from the microphone, make it a bit more sensitive.
Yep.
But it works okay, that's pretty cool. And then the other feature was the motor driver that I thought we'd have a look at.
Okay.
So if we have a quick look at the example program, all I've done here is, again, I'm using an analog channel. We've got a potentiometer connected to that, so we're going to use the potentiometer to determine how fast to drive the motor. And this, so here's the pot, and the motor's just blue tacked onto the side in true hacker style. So as we turn the potentiometer, we're going to read the voltage from analog channel 2, and that voltage will go from 0 up to 5 volts. We're using the 5 volt rail for this one. And then we're transforming that voltage from 0 to 5 volts into a value that's between -100 and +100, which is what the Explorer Hat library expects. And then we'll just set the speed of the motor. So as simple as that. So, there. So just turn the potentiometer and change the speed of the motor. There's two nice things about the motor driver on the Explorer Hat Pro. One is that it's variable speed, and the other is that it's an H-bridge, so it lets you drive the motor in both directions, which is dead handy for making little buggies and robots. And an H-bridge is literally a circuit that will allow you to invert the voltage across the motor. So the speed control is done via PWM, and then the H-bridge provides the kind of voltage direction reversing.
Fantastic.
It's a cool feature.
Indeed.
Cool.
That was it, I think, for that.
Yeah. Right. What does we have next?
We have questions from our viewers.
Ah.
So, Sandy McDonald has asked, what features would we like to see on a Raspberry Pi 3? What more could we ask for? It's already perfect,
Wi-Fi.
Sandy.
Wi-Fi.
Oh, Wi-Fi would be cool, but
Wi-Fi.
really, I don't know. Could it be any cheaper? I think it's fast enough now.
Well, people always ask for things like SATA and kind of stuff like that, stuff that they equate with kind of your desktop PC things, really, and gigabit Ethernet. Yeah.
Isn't
I want
that
gigabit
what a
Ethernet.
USB 3 would
That's
give
all
us,
I want.
basically?
Yeah.
If it had USB 3, then all that stuff could just be added on.
Yeah, the chips are so expensive because there must be massive license fees from that still.
Oh, of course, yeah.
Yeah, and it's just gonna add massive cost to something like the
Didn't
Raspberry
say our
Pi.
expectations had to be realistic.
That's a very fair point. But I think we
Yeah.
should be, because we're product designers. So
True,
yeah.
true.
I think, I think the I used to always whinge about the CPU on the B+, and I whinged to Paul about it. It's too slow, it's really annoying, because I like writing lazy code in Python. But actually, since the 2 came out, I think the CPU is just fast enough. I mean, you could go 8-core, you could go slightly faster, but it doesn't feel like a hindrance anymore, so what more do you need, really?
Yeah, they've released the faster processor. Now they're working on things like the web browser in the background to make the code more efficient and make better use of the processors. Just to turn it into more like that desktop PC experience, really. So it can be used for web browsing, it can be used for document editing at a pinch, and there are less kind of questions about using it as a main kind of PC for a kid.
I mean, gigabit Ethernet would be really nice, because that would mean you could start using it as a NAS and things. I know a lot of people, when they say, should I use a Raspberry Pi as a NAS on, say, Reddit or Hacker News or whatever, people say no, use the Odroid, just because it has the gigabit Ethernet.
Yeah, it's just that bottleneck of Ethernet and USB.
Yeah.
It's kind of a double whammy of...
Does the Odroid have a SATA connector as well?
Not that well. They have quite a few different models in different guises. I don't think the C1 does.
Yeah.
Maybe they've got other devices that do.
It kind of appeals to geeks like us who want kind of the sandwich and the wheels and whatever on things for next to no money.
Having said that, though, I think stuff like SATA and wireless, if you can upgrade the USB stack, that's easy additions using very cheap add-ons. So I wouldn't be worried about that too much personally. If the USB was faster, I'd be more than happy to buy a decent Wi-Fi dongle, decent SATA bridge. But if the USB is not kind of up to the standard required to make that fast, then you're always going to be held back, I guess.
Yeah, you are a little bit, but yeah, that's kind of when you're kind of serving big files, which I suppose videos mainly.
Yeah, but the Pi 2 is pretty good. It's like an amazing upgrade on the B+ and B. So
Really
The
is.
fact that people do
we ain't
coding with it
complaining really.
perfectly well.
Yeah.
Yeah, it's still one of the best experiences for media streaming, especially at that price.
Yeah, definitely.
Because just the community, Kodi, OSMC, OpenELEC, they've just put so much work into turning a small computer into a really slick experience. And I know the Pi Foundation actually helped with that process as well, supporting the open source projects, which is great.
For sure. No, I think that's good.
Yeah.
So there you go, Sandy. And Ian has asked, oh, here we go again. I really like the Pibo timber case, and I have one for my Model B. You no longer make it. Why is that? And is there any chance of it coming back?
The spruce we use does not travel well. So if it gets dry, if it gets brittle, if it's been, say, shipped in a cargo airplane, then when it arrives anywhere outside the UK, it tends to be just too brittle for transit. When you build it, it's fine. But again, along with being brittle, it might have shrunk slightly, and then it's a real bucket to build.
It's wood. It's a living thing. It's full of moisture and.
Well, because we've got quite thin sprues as well, and we don't want to make a large, ungainly case. Really,
No.
It's not something we're particularly interested in.
We've looked also at doing it out of stuff like laser ply, 3mm MDF, but it just doesn't look like good.
The Plibo just fell.
Oh yeah, Plibo.
Yeah. No.
It just wasn't cool, and it's a real shame. We love the timber as well, and it's just not viable. We just can't do it. You can't ship it outside.
We tried walnut, but it doesn't give a very nice finish. There's a lot of carbon on the edge, which we don't like next to electronics. The spruce just happened to have a lot of resin, so when it cut, it ended up looking varnished along the edge, which was just this random happenstance thing that worked, so we went with it. Yeah. But yeah, it got to the point where we had to charge more for it, and we would have, with the kind of number that didn't make it through shipping, we would have ended up charging too much for it, really. So we kind of left that alone. I think most of the wood cases we've seen, some are quite good. They use more chunky kind of veneers of wood.
Yeah, and living hinge style ones as well. Where it's kind of
living
solid
hinges
piece.
just don't last that long though. They're
No,
just
but
not
I
that
suppose
robust.
it's in a case. Like even over time, will they just get brittle and essentially give eventually?
Yeah.
There you go.
And Sandy says, when's the leather Pibo coming?
Paul's saving that one for himself.
Yeah, smells like dead pig. It's not nice. Yeah. But you can get these really nice two-tone leathers where the kind of solid top and the softer backing are two different contrast colours. And when you laser etch that, you end up with a really nice effect. So sometime next year, I might try one or two of those as kind of giveaways, just because.
Well, it'd be like an old style desk, right, with just the leather surface.
But then just etched away in a nice pattern, so you get kind of this contrast colour punching out.
There you go. You heard it here first. Can we say?
Yeah.
So we'll all just shed a small tear for the Pibo timber.
Yeah.
And move on.
Yeah.
And then I think we just got a couple of kind of either new or interesting products from the store to have a look at, which maybe you haven't discovered before or haven't seen, but we kind of like them. We think they're pretty awesome. This is SparkFun's new XZ sensor. It uses a couple of
called the library XY actually because
XY sensor.
But it is XZ because your Z is that way and your X is that way.
Yeah. And it's a pretty simple concept, but it's been nicely put together. Basically, they've got a couple of infrared emitting diodes in the little copper cans and a sensor in the centre, and there's a PIC microcontroller underneath. I assume what they do is turn on the LEDs one after the other and take a reading, and then work out roughly where the object is over the sensor. So it's not like Skywriter that gives you the full XYZ, but this is great for just doing basic gesture over the top or sensing the distance to an object.
Yeah, I was playing with it earlier and it kind of felt like it should be able to figure out at least approximately kind of what side a wall is coming from when it's sort of veering off course.
Oh, if you put it on the front of a buggy or something.
Yeah, it might be able to correct course before it even collides with a wall. It's worth looking into that.
We're playing with an idea that's similar to this for a future flotilla module that has an array of IR sensors. So rather than just having a single kind of bump sensor, you've got this little line of them, so it can see a really rough shape of the object that's in front of it for kind of collision avoidance and stuff. So that'll be coming in the future, hopefully. You got a little demo of this, Phil?
I have got it up and running, but there's no Python library that I could find at the moment, so I just started writing one.
Oh, we'll have
like
one
you
soon.
do. Yeah. So we'll have one soon. I've got a little demo that's just throwing out the X and Y coordinates on the screen here, which is probably very difficult to see. I haven't got the luxury of an HDMI cable in mind.
Wow, sorry, Phil.
But yeah, you'll be able to get the X and Z coordinates out of this, which you can use to do some interesting things about figuring out where something is coming from. And I was wondering whether or not I could do kind of note that way and maybe strum that way for some kind of air string instrument or piano.
Always back to the theremins, isn't it?
Everything ends up being musical.
They say that the range on this, I think, is about 25 centimetres.
It seems to appear around here. You should be able to see it on the screen. Let's have a look.
Yeah. Oh, yeah. That's actually a bit better than that, isn't it? I'd say 40 centimetres.
And then it kind of comes down to 0 about there. So.
Down to, what, maybe 10 centimetres.
Way before you hit the wall.
Which is good. That's what you want, really, if anything. Yeah, it's nice. And you can talk to it via I2C or UART. It has both interfaces. And I'm pretty sure you actually get gesture outputs
so
from it, as well as the X
gesture
data.
from left to right, right to left, and from up to down as well, but not from down to up, I think I found.
Whoa. Okay, fair enough.
But I think the library, well, it has a PIC microcontroller on the back of there, and you can write your own software for it effectively, if not modify the software that's on there.
Yeah.
At the moment, it supports sending data via serial, so UART, so you can actually see what it's doing, but not receiving commands via UART.
No.
So I think there's work to do on there.
Okay, cool. Yeah, that's nice. And that neatly segues into the other product we're going to look at, which is underneath it.
The cake board.
Let's have a look.
So this is, when was this released? Quite recently by some bonkers guys.
It was a Kickstarter by Breadboard Maniac.
Yeah, very interesting things with breadboards, including a wooden one that costs...
Yeah, they do a wooden breadboard that costs
like
as much as a small family car or something.
It's
But they
very
just
useful
do
thing
interesting
indeed.
prototyping tools, and this was a Kickstarter for basically, the next generation of prototyping breadboard. Breadboards have been the same for, well, the ones we buy now are the same as I had like 20 years ago when I was doing this stuff as a kid.
Yep.
And they just had an idea of how to make that better, and the cake board was the end result of that.
The kind of novel thing about it is in the centre there, it's got a split down the centre. So if you take a close look again, you've got two areas in the middle that are split down the centre, but it doesn't have a big gap. So if you've got something like the Pi header, the 40-way header, you can actually put that directly onto the board and split it.
Maybe be careful about this.
Yeah, no, if you've got a cable. If you've got a
It's
cable.
already got stuff going into it.
Yeah, I don't want to fry the pie. So let's take all the stuff off and let's just plug that straight into the top there.
There we go. So yeah, standard dual inline header basically. You
Still
can plug
works.
across the centre of the breadboard,
Yep.
which is great. You can't do that normally. The other thing that this is showing is that you can actually plug things into both sides of the breadboard. So you can plug the Pi into the bottom and then do the circuit on the top, which is just it's kind of awesome. It's a bit hard to tell where the pins are now because they're occluded by the board itself.
I guess if you
you're
align
careful,
it right to the end, then
Yeah.
you should be able to use the numbers. There are little dots here marking every 5th pin, or every 4th pin actually in this one. So you can just align it right to the bottom edge there, and then you'll be able to count your pins along on the top.
Yeah.
It's basically the only way you're ever going to know what pin you're dealing with.
And it's got the normal power rails at the top. So it's quality stuff.
Well, it's got the power rails actually line up with the holes as well, which for anyone who's come across a breadboard and found that the power rails are slightly out of line with
Just
the holes,
offset.
and that's driven them crazy. They fixed that. Mounting holes in the corners are really nice, and they fit our M3 nylon bolts.
they're also Lego compatible, aren't they?
And yes,
I
they
think
are Lego
they're-
compatible. You can take a little round Lego stud or one of the small square ones and just plug it into the bottom there.
Yeah.
And build your kind of Lego breadboard contraption.
We'll include that when we do our kind of Bilge Tank Lego special,
Oh yeah.
which is a great excuse to play with Lego. We don't get to do that enough.
Not enough.
Yeah. Couple of questions from Twitter. Max Warren asks, can you give us a rough estimate of when you think Flotilla will be distributed to Kickstarter backers? At the moment, the main things holding us up was we made another error in the dock. We got back our prototypes and they were perfect, apart from those fiducials we mentioned earlier.
Those pesky fiducials, Phil.
Those pesky
In the
fiducials.
rush, we all missed the fact we hadn't included fiducials, so now it needs to go through another golden sample run, which is due back, I think, on the 29th of this month, or thereabouts. And then once that's okay, we need to go through another 3-week production thing, and that's the thing that will stop any kits being shipped, because they all include the dock. It's the heart of all the kits. But then after that, we've got touch, rainbow, light, and
barometer, weather.
barometer weather in stock, which are the core of the small and the medium kits. So we've started producing a small number of those to shake down our production process so that they're ready to go when the docks arrive and are there. So I think that gives us kind of 5 weeks at the moment before we can even start shipping conceivably, and there will be some delay with actually packing stuff because Flotilla has a lot of bits in it. So we're still kind of 6 weeks away. It's always 6 weeks away.
Yeah, we are actually starting to pre-kit things like the ropes and the wheels and like Lego motor shafts and all that kind of stuff. So it's just ready to throw in the box. But yeah, we need the docks basically. We don't have any docks yet.
Yeah, the dock's been the most reworked piece we've done.
Yeah.
It's worth saying that it survived very, very well at Leicester Maker Faire. 2 days of running non-stop solid on a shiny new minted Flotilla dock without fiducials, but
yeah, just means G has to
on
do
the
a
back
lot
of
of
a
hand
robot.
placing, which is just not a fun prospect. Okay, Badly Drawn Burns asks the best place to start learning Python.
Wow, I don't even know. I can't even remember how I started learning Python.
A lot of people recommend Python the hard way,
Yeah.
which if you're of a certain frame of mind, if you like practicing until you suddenly become really good at something, then Python the hard way is one way to start that gets recommended.
That's learnpythonthehardway.org is the website.
Yeah.
There's also a book, or it is only a book or something. I don't know. But there's just loads of stuff online.
Yeah.
I mean, dive in and start looking at stuff. Try and work out what you want to do. Go on Stack Overflow. It's
Yeah,
it's
every
all
time you
online
hit
these days.
every time you hit a wall, go look on Stack Overflow or Google.
I think
if you
everyone learns in slightly different ways, don't they? Some
Yeah.
people will take a book and consume it start to finish, and some people will take a challenge and then learn as they go and try and meet every kind of hurdle of that challenge.
Other
Yeah.
people will download some existing code and just pick
Yeah,
it
just
apart until
modify
they
it,
kind of
pick it
understand
apart,
what's
glue it
going on,
together.
which I think is a good approach.
Yeah, that's the top-down learning approach that we always talk about. You'll see Adafruit doing it, SparkFun doing it, and us doing it. Learn.pimoroni.com, learn.adafruit.com, and I think learn.sparkfun.com. It'd be really nice if kind of pretty much every website that had knowledge, that had information, kind of shared in that way, so you could always go to learn. To get stuff. And of course, raspberrypi.org/resources. There's lots of examples of projects to do there, which half of them will probably include Python code that you can look through and learn from just by pattern matching.
Yeah,
Humans are pretty good at this.
Just checking on our learning portal, we've got 13 projects that are primarily written in Python. So any of those you can jump
It's all
in,
very
grab the
project
code.
orientated at the moment, but I actually do have in progress a couple of specifically Python articles that kind of go into the nuances and the kind of gooey bits of Python and try and teach you a little bit about things kind of in a meaningful step-by-step way. So Learning Portal soon will have some Python for the sake of Python material on there, rather than Python for the sake of Explorer Hat or Unicorn Hat.
Yep.
Super.
Okay.
Wow.
And I think we had one more question from
Oh,
Neil Matthews. Talking of Pybos, and I think he's making a subtle reference there to the e-paper Pybo. Neil, through Percheron Electronics, recently did a Kickstarter, which was an e-paper hat for the top of your Pi. Very good stuff. Takes very little power. Still works when it's switched off. And we do have a Pybo design for that, which now we've just about caught up on the deluge of orders for the frame for the official screen. We should be able to squeeze some of them out fairly soon.
Don't squeeze too hard or you'll crack the e-paper.
Yeah.
Yeah, they're very delicate, but once they're in a Pybo, nice and secure.
Yeah,
Just
delicate.
be careful putting it together.
Like a beautiful butterfly.
Yes.
Yeah.
Don't stamp on it.
Okay.
I think that's it for this week. So we'll see you all next week for Bilge Tank 003.
Thanks for watching, folks.
Bye.
Bye-bye.
Bye-bye.